2.4, 30 and 38. 30, if the measure of angle A is 29 degrees and the measure of angle B is 29 degrees, then the measure of angle A is equal to the measure of angle B. Well, what property would this be? Because what property dealt with this here? This is the transitive property of equality. And that was problem number 30, yes? And then 33? 38. 38 said, if 5 parentheses x plus 8 is equal to 2, then blank plus blank equals 2. And it said distributive property, yes? Well, our distributive property is we're distributing the 5. So 5 times x would be, and 5 times 8 is, and that's it. So really on 33 through 40, it's just asking you to apply it. So since it was talking about the distributive property, we would distribute it. If it's the transitive property, we finish out the statement. Any other questions on any of the homework assignments? All right. If there are no other questions on any of the assignments, let's go on and look at today's lesson. Now, what we're going to be doing is proving mathematical statements by doing a proof or using a proof. Now, what we're going to do for the most part today is go on and fill the statements out and show how we would go about proving something, one step at a time. Now, these first few, we're going to fill in the missing information for how we got from start to finish. Now, with any geometric proof or any proof, we're always going to start with the given information. Now, they told us that AC is equal to AB plus AB. Well, what did we start out with? AC is equal to AB plus AB. We started out with the given information. Now, what do we want to prove? AB is equal to, what's our last statement? AB equals BC. Because we're always going to start with the given, and we're going to finish out with what we're trying to prove. So let's look at this second statement. AB plus BC equals AC. So what did we say? The two parts equal the whole thing, yes? Do we have a postulate that lets me say that? We should. Would be our segment what? Anybody remember? It's our segment addition postulate, because again, the segment addition postulate says that if we have 3 points on a line, AB plus BC is going to equal to AC. The two parts will equal the whole. And that's all we're saying here, that AB plus BC, the two parts are going to equal the whole. That's our segment addition postulate. Any questions on this here so far? Question? Okay. Now, so far we've said AC is equal to what? AB plus AB, yes? We also said that AC is equal to AB plus BC, yes? Wasn't there a postulate that we learned on Friday that says I can take these two statements and together because they're both equal to AC? We did, and it starts with a T. Does anybody remember? Transitive, yes. Property of equality. Because the transitive property of equality will let us put those two statements together. If we're taking two statements that have something similar, so AC and AC here, we're going to use the transitive property of equality. If we're just plugging a specific value in, we'll be using the substitution property of equality. Now, what do both statements have in common? Well, AB, yes? And that's just a measure. It's just the length AB. It's just a specific number, yes? So we can do what to get rid of it from both sides? We can not divide, but subtract. Because we can use the subtraction property of equality. Because we can subtract AB from both sides, which would just tell us that AB is equal to BC. And that's it. That's all we have to do. The more that we do, the better that you'll understand what we're doing. Any questions on this here? Any questions on this so far? Because that's all we had to do. We finished it. Okay, let's look at another one. So we're going to do this together. So we want to fill out the rest of the steps. Now again, whenever we do a proof, what do we always start with? So what is the given information? The measure of angle 1 is equal to the measure of angle 3, yes? Do we have that already filled in? No. So in statement 1, we can say that the measure of angle 1 is equal to the measure of angle 3. We start with the given and we end with what? What we want to prove, yes? So on the last step, do they have that? No. So the last piece is going to be that the measure of angle EBA is going to equal the measure of angle CBD. Now on the test, I will give you all the spaces out that should work out for the number, and you'll fill it in like we're doing here. Now we do only have 2 other blanks, but let's work down to how we get there. Now in part number 2, they tell us that EBA is equal to 2 plus 3, the measure of angle 2 plus the measure of angle 3. Well, that's our angle addition postulate, because the 2 angles add together to give me the entire angle. Yes, we remember doing that the other week. That's just the angle addition postulate, that these 2 angles add together to give me the whole angle. Now, what did we say in our first statement? That measure of angle 1 is equal to the measure of angle 3. Those were the same. Well, I can substitute the measure of angle 1 in for the measure of angle 3, which tells us that the measure of EBA is equal to the measure of angle 2 plus the measure of angle 1. Those will give us the exact same value. Now, what they're going to do next, and we're not going to be as meticulous as this, I'm not going to make you be this meticulous, but they want us to switch them, switch 1 and 2. And that there is our commutative property of addition. And it really just says we can add any 2 things in any order. That the measure of angle 2 plus, or measure of angle 1 plus the measure of angle 2 is the same as the measure of angle 2 plus the measure of angle 1. It doesn't matter in which we add. Order does not matter with addition. Okay. Any questions on this here so far? So what are we wanting to prove? That EBA and CBD are the same, yes? So we've already mentioned a good bit about EBA. Have we talked about CBD yet? No, but we need to define it, yes? And the angle addition postulate, they kind of gave us this hint. Come on. So, CBD, what two angles add together to give me CBD? 1 and 2. So on step 5, measure of angle 1 plus the measure of angle 2 would be the measure of what? CBD. Yes. And now because of our transitive property, since we have 1 plus 2, the same as 1 plus 2, so those two angles are equal. That's it. Questions on this here? All right. Now this one here is going to be the first proof that we have where we don't have anything filled in. But we're going to work it all the way through. So when we look at this here, they give us that the measure of angle 1 is equal to the measure of angle 3. So what's our first statement going to be? The given that the measure of angle 1 is equal to the measure of angle 3. Well, why do we know this? Because it's given. It's the given information. Because we're always going to start with the given. Now, statement number 5 is going to be what? What we want to prove, because we always want to finish at what we want to prove. Well, and that's going to be that the measure of DBA is equal to the measure of EBC. EBA, the measure of DBA is going to equal the measure of EBC. But those two angles are going to be equal. Now, what we're going to start off with first is we really need to talk about one of them or define one of these two angles based off the picture given to us. Now, we can start off by saying that DBA is composed of what? Two and 3. As we can see from the diagram, the measure of angle 3 and 2, if we add those together, we get the whole angle DBA, yes? What postulate am I using to say this statement? See? So what kind of measures are we talking about? What are we talking about? These here are, they're not segments, they are angle. So this would be the, come on, angle addition postulate, because the angle addition postulate says that the two smaller angles will add together to be the bigger, in more or less terms. Any questions on how we got to this point here? Now, what do I know about EBC? Well, it's 1 plus 2, yes? So it'd be nice if I can say that DBA is using measure of angle 1 and 2, yes? Well, wait a minute. What did we say about angle 3 and angle 1? They're equal, so I could replace the measure of angle 3 with the measure of angle 1. And this here would be the substitution property of equality. The main difference between transitive and substitution is how many values did I replace with this statement here? Well, 1, that's kind of the same with transitive, but transitive requires how many statements? 2. because A equals B and B equals C, so A is equal to C. I'm taking two statements together. Here, I have one statement and I'm plugging a value into it. I'm replacing 3, the measure of angle 3, with the measure of angle 1. Any questions on this here? What is the one thing we have not mentioned anywhere in our proof, besides at the very bottom? Is it EBC, angle EBC? Because have we defined angle EBC at all throughout this proof? No, so what would we need to do next? Say that the measure of angle EBC is 1 plus 2. Because I can scroll up. Because EBC would be the measure of angle 1 plus the measure of angle 2. That's what we can see in the picture, yes? And our postulate for this would be the angle addition postulate. And last but not least, what would our last part be? Transitive property of equality. Because we said that dBA is equal to the measure of angle 1 plus the measure of angle 2. We said the measure of angle 1 plus the measure of angle 2 is equal to EBC. Two statements where we have a commonality of the measure of angle 1 plus the measure of angle 2, which means those other two angles must be equal according to the transitive property of equality. That's it. That's all we have to do. Bless you. That's the proof. That's the entire proof. Questions on this here? Okay. Be ready for the next one. Okay. 6 steps to a 2-column proof as shown. Copy and complete the proof. So what did they tell us to start with? What is our given? Okay. So our first statement, T is the midpoint of SU. Our reason for it is what? Given. Okay. It is given. Well, we can't fill in space 6, but they already did fill in the last part of the proof that x is equal to 5. That's what we wanted to prove, yes? So T is the midpoint of SU. Well, the midpoint does what? It divides a line segment into congruent segments, yes? That's just what a midpoint is. So what do? T is the midpoint of SU, so the next thing they said was that ST is congruent to TU, because that's just the definition of a midpoint. Well, the reason we can say it is because of the definition of midpoint. That's what a midpoint is. Well, if two segments are congruent, it means they have the same length. So we can say that ST is equal to TU. Now, if we were just trying to talk about segments and we're not talking about length, we don't need that step. But what are we wanting to find? The value of x. We're trying to find a value, so we have to talk about the length. And the reason that we could say that their lengths are equal is the definition of congruent segments. That's what it is. Questions on this here? Okay. From here to here, what are we doing? Well, ST is 7x, yes? And TU is 3x plus 20, so we use the substitution property of equality. Because we substituted 7x in for ST. We substituted 3x plus 20 into TU. We substituted those values in. Any questions on this here? Now, what do we think we're going to do next? Subtraction. We're going to subtract, yes? Because the property they told us that's going to happen next is the subtraction property of equality. So what can we subtract from both sides? we can subtract the 3x. Because we can subtract 3x from both sides. Because 3x minus 3x will be 0. So that leaves us with 20. What is 7x minus 3x? So in spot number 5, we really have that 4x equals 20. Now what would we do from 4x equals 20 to get that x equals 5? We divide both sides by 4, which is our, so the last spot would be our division property of equality. Division property of equality. Division property of equality. Now, on the test, most of the test is going to be like this here for these proofs. For the geometric proofs, I'm going to have them partway filled out. You have to fill in the rest. That's how I'm going to do the geometric proofs. The algebra-based proofs that we did Friday, you'll remember doing those starting out with like 2x plus 7 equals 8x minus 10 and stepped it all the way out. Those will be completely blank. Because I feel that you all are comfortable doing that. And I want to leave it to where you can solve it whichever way you want to do it. If you want to add the 20 first, or you want to subtract x first, or depending on which one you want to solve first, I'm going to leave it up to you instead of forcing you to do it a specific way. So those are going to be more open. These here on the test is going to be exactly like this here. You're going to fill in the blanks to get to the end of the proof. So hopefully, the first two should be easy points. T is the midpoint, it is the given. Those should be given, and the last spot is what we're trying to prove. So any questions on this here? You can write these down if you want. They are also in your reference sheet. They are on your reference sheet. The reflexive property of segment congruency. Well, for any segment AB, segment AB is congruent to segment AB. Symmetric. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Transitive. If line segment AB is congruent to line segment CD, and line segment CD is congruent to line segment EF, then line segment AB is congruent to line segment EF. Isn't that the exact same transitive property we had on Friday? If A equals B and B equals C, then A is equal to C? Yes, the only main difference is here we're talking about what? Line segments. We could also talk about properties of angle congruency. For any angle A is congruent to angle A. Or symmetric, if angle A is congruent to angle B, then angle B is congruent to angle A. We can have it in either order. And lastly, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. These are the exact same properties we had for symmetric, reflexive, and transitive on Friday. Questions on this here? If you didn't get those all down, the reference sheet I gave you all on Friday or the other day does have them all there. So, if angle T is congruent to angle V and angle V is congruent to angle R, then angle T is congruent to angle R. What would this be? Property of what? Because here we don't have equals. Congruency. But we need one more letter. Yes. angle. Because all three of these here are all what? Angles, yes? So it's the transitive property of angle congruency. Well, I know it's angles because P, V, and R are all angles. We have the angle marker, yes? And the symbol between them is the congruency marker. Well, I know it's transitive T, V, and V, R, and then T, V, TR. So it would be the transitive property. Well, they're angles, and it's talking about congruency. If line segment JL is congruent to line segment VZ, and line segment VZ is congruent to line segment JL. This would be our, what? Symmetric property of what? Segment congruency. Because we're going to need the whole thing. And luckily for segment congruency and angle congruency, it kind of tells us, because what are we talking about? Are we talking about angles or segments? And if it is equal, then it's equality. If it's our congruency marker, then we're talking about congruency. Any questions on this here? All right. Well, the next proof we're going to do is we're actually proving a symmetric property of congruency. We actually want to show that the symmetric property of congruency does work. Now, so far, we've already proven that the symmetric property of equality is true. If A equals B, then B equals A. We know that's true. So we're going to use the symmetric property of equality to show the symmetric property of congruency is true. Well, our first statement is going to be what? The given. LM is congruent to NP. And what's our last statement going to be? Yes. Well, we want to prove that NP is congruent to LM. We're wanting to flip it, yes? So, well, we know that these two segments are congruent, yes? So if they're congruent, that means they have what? Two things are congruent. They have the same length. Because that's just the definition of congruent segments. Because if two segments are congruent, then they have the same length. They have the same measure. So we could say that LM is equal to NP. Well, what we learned on Friday is that I can switch them and say that NP is equal to LM because of our symmetric property of equality. Because the symmetric property of equality says I can flip it. Well, if they have the same length, it means that they are congruent, yes? How do I know that? It's one of our definitions. For what? Congruent segments. Any questions on this here? So really we start off with the given information. Line segment LN is congruent to line segment NP. Because they are congruent segments, it means their lengths are the same. Symmetric property of equality says I can flip it. And again, because they're still equal, it means that they are congruent. All right, guys, so